Hey everyone, welcome to another video. We're looking at the cosine rule in this video, going on with some more non-right angle trig. Now, in this video, we're just going to introduce this rule here. So this is the one I've written down here. This is that one side, c squared, equals to a squared plus b squared, so the other two sides squared. Now let's actually highlight this here. So c squared, this side here, equals to a squared plus b squared, so any other side other than the ones we have, minus 2 times a times b, and the cos of the angle c. Let's do this in green. Okay, so we're introducing this rule here. In the next video, we're going to derive it, actually come up with this rule, if anyone's interested. But in this video, we're just gonna introduce this rule and just go straight into using this in order to find unknown sides and angles of non-right angle triangles. Now, where this rule is useful for is when we're only given one angle. So previously with sine rule, we noticed that it was really helpful when we were given two angles and one side opposite one of those angles. Cosine rule is really helpful for when we have two sides given. So in this case, it's going to be A and B, side A and B on our triangle, and one angle, the included angle in between those, which is opposite to my third side, C. So let's just jump straight into an example and we will look at how we can use this particular rule. So I've got this triangle here. I have an angle of 102 degrees. I have a side of 2 centimeters here, 3 centimeters, and I have a side A here. Now, the side that is the subject of the equation, as we see up here, that is the side that is the unknown, the one we want to find. So in this case, the side A we want to find is going to be on the left of our equation. So this, what acts as c squared here. Now the pronumerals don't really matter. It's more, we choose what to put where based on what the question is essentially giving us. So let's call this side A. Let's call this side, let's do it in a different color, B. Let's call this C. So my side A is going to be the subject of the equation. So here we're going to do a squared equals to the other two sides squared, sum of the other two sides, so b squared plus c squared, minus, from that we're minusing, 2 times those other two sides times the cosine of the angle we're given. So here this is going to be 2bc cos A. Okay, now let's actually substitute this stuff in. So for my a squared, that's my unknown, I'm going to write that here. And I'm going to put 3 instead of b. I'm going to put 2 instead of c. So I get 3 squared plus 2 squared minus 2 times 3 times 2 times cos of the angle that is opposite my unknown side. So my angle of 102 degrees, this is my angle A here, for example. And we call it, for example, angle capital A, just to show that it's the angle opposing my unknown side here. So instead of A here, I'm going to put 102 degrees, the angle opposite my unknown side of A. And now we can just solve it. So before we do though, we have that, not that A equals to the right hand side, A squared. So I can find what A is by taking the square root of both sides. So my side A is going to be the square root of all of these things. b squared plus 2 squared minus 2 times 3 times 2 cos of 102 degrees. Okay, and when I put that into my calculator, we can round this to 2 decimal places. That equals approximately 3.94 centimeters. Okay, so this is how we can use cosine rule to find an unknown side. Let's look at how we can use it to find an unknown angle. So I'm going to give you another triangle here. And it's important to note here, all of the triangles we're working with here are going to be non-right angle triangles. This is why we need these new rules, because we're using trigonometry in a slightly different way. And we have my angle theta here. Okay, so first of all, we're going to write out my regular cosine rule in the current form we have it. So let's call this side C, let's call this side A, let's call this side B, and let's call this angle C, or theta. Let's leave it like this. So my normal cosine rule equation is going to be C squared, the one opposite my angle that's given here, equals to A squared plus B squared minus 2 times A times B times cos theta. Now, what is important to note here is that we are trying to get to theta. That is our end goal. And we have an equation here. So what we're going to do is we want to rearrange this equation to first make cos theta the subject, and then we're going to use that to find the actual theta itself by taking the inverse trig operation, which we've talked about before. But for now, let's just rearrange the equation to make cos theta the subject. Now, it's a little annoying on this side with the negative 2ab, so let's move that to the other side in order to make this positive. So I'm going to add 2ab cos theta to both sides. Cool. So this is going to give me, on the left hand side, positive 2ab cos theta plus c squared equals to a squared plus b squared. Alright, now I want to systematically chip away at everything surrounding cos theta in order to get it on its own. Now the first pretty clear thing I can see is this plus c squared. So I'm going to subtract it from both sides. So that leaves me with 2 times a times b cos theta. That equals to a squared plus b squared minus c squared. Now we're almost there. Now it's important to note that the 2ab is getting multiplied by cos theta. So I can get it onto the other side, leaving cos on its own, by simply dividing both sides by 2ab. That's going to clear this, leaving us with 1 times cos theta, or just cos theta. And remembering that when we solve equations, what we do on one side, we do to the other. So I'm left with cos theta here on its own equals to a squared plus b squared minus c squared over 2ab. Alright, now we have it in this form, and we already have cos theta as the subject. So I can substitute in all of my elements here into my equation in order to get to theta. So instead of c, I'm going to put 8. So, okay, instead of c, I'm going to put 8. Instead of a, I'm going to put 13. Instead of b, I'm going to put 12. So we get here 13 squared, because I'm substituting in 13 for a, plus 12 squared minus 8 squared. Now, it doesn't matter which side you pick for a and b, so long as you're picking the sides that are not the one opposite to theta. So you could have had a as you could have had a as 12 or b as 13. It doesn't matter as long as your c is opposite Your side C is opposite to the unknown angle. Now let's finish this up. This is going to be over 2 times 13 is A here, times 12 for B. Okay, so I have all of this. Now, that's going to give me, once this gets simplified, that cos theta equals to 249 over 312. And the last thing I want to do, because cos theta is equal to this, I want to get to theta. So like we did with the right angle trig, I can isolate my theta, my angle, by taking the inverse sine of both sides. That gives me theta on its own. Oh, sorry, not the inverse sine, the inverse cosine. I'm taking the inverse cosine of 249 over 312. So by doing this, I can isolate my angle. I can find what this value of theta is going to be. And that's going to give me approximately 37.053 degrees. Or I can also write this in degrees and minutes. That also equals to 37 degrees and 3 minutes. And this is to the nearest minute. So we use cosine rule in 2 particular ways. One is in this form up here, where we have the cosine rule for when we want to find an unknown side. So let's actually write this in here. This is for the unknown side. And we can see that one of the sides, C, is the subject of the equation. So we're looking for a side. Or we can rearrange this equation in order to use cosine rule to find a unknown angle. So we're using the same formula just in 2 different versions in order to find 2 different things. Now what you pick is going to depend on what the question's asking you, whether it's for an angle or for a side. And remembering here that the sides we pick, so what we pick to be the subject of the equation, has to be the side opposite our given angle. So the order, at least for my side that's the subject of the equation, is going to be important. That side is the one that is the subject here on its own. So we have to be careful when we use cosine rule in these particular cases. But that's how we can actually use cosine rule, and in the next video we're going to look at actually deriving this. But thank you so much for watching today, and I'll see you next time.